Hello. Can you hear me? If you can hear me, say hi in the chat. Hello, Nathan and Mia, as well as Basement Ghost. And Niraj. So it might take a few minutes for everyone to come in. During that time, let me ask you guys a few questions. First of all, how far along are you in your JavaScript journey? So are you a complete beginner, or are you someone who has years of expertise in JavaScript? Go ahead and answer in the chat. So we have Jake Cheek, who's a beginner. Nathan's a rookie. I guess that's a little above beginner. Basement Ghost is a beginner. Are you guys following any particular courses like Code Academy, Free Code Camp, Udemy, or any particular creator that you find helpful? If so, say it in the chat. The Odin project from Basement Ghost. I've heard good things about the Odin project. They also have a chat. Discord. They have a Discord channel with like hundreds or even thousands of users. Mia is watching Maximilian Schwartzmuller. I've heard good things about him too from many of my students. Jonas Shemman. A lot of consonants there. I don't know that particular creator. Thanks for sharing, Mia. Nathan uses Udemy, but took a while to find a creator. It's hard to find creators. You have to find a creator who teaches in a way that you like and who teaches at the level where you are. So if you're a little more advanced, someone who teaches to complete beginners will be going really slowly and will not be covering things in depth. But if you're a beginner, you can't follow someone who expects a certain level of knowledge because you'll be lost. So finding a good creator is tough. All right, well, we have 14 people watching now, so I'm just going to get into it. Into the main part of the show. Okay, so today's presentation is building a good JavaScript foundation by training your brain to think like a computer. This is a very important topic because I've been teaching for years, and students who struggle, it's because of a weak foundation. That is one of the biggest factors that will determine how well you can learn and how effective you'll be on the job. So, a bit about myself. I'm Jacques. I have a master's in computer science because I loved computer science and I decided to continue. I'm an ex-Google software engineer. I quit because I really wanted to share my love of programming with people. And I wanted to help people, and I wanted to see the difference I was making in people's lives. I'm the previous head of education at Concordia Boot Camps. I was the head instructor. I was also managing another instructor, and I set the curriculum from A to Z. You can check out my reviews, the reviews of the students on Course Report to see how I did. And I'm the creator of a platform called Wakata. We'll be talking about that in a few slides. So, to date, I've taught many students to overcome the elephant in the room when it comes to becoming a developer. No matter how advanced you think you are at coding, unless you train your brain to think like a computer, you will never have what it takes to write beautiful code, and you will run into a lot of problems, both in the context of your individual projects and your professional career. By the way, if at any time anyone has questions, please put them in the chat. You can ask anything. You can ask me, why did I quit Google? You can ask me what an elephant is. There's no such thing as a bad question. Next slide. So, what do I mean by training your brain to think like a computer? Specifically, when I talk about JavaScript. Well, I'm talking about understanding exactly how a computer, which has a brain that's quite different from the mind of a human being, interprets JavaScript code. I'm talking about what actually happens inside the brain, also known as random access memory, of a computer when it reads your code. So I'll explain much more about this as we proceed through the workshop today, but for now, I want you to know that I've created an online learning platform called Wakata, which has been thoroughly vetted by over 100 students who attended my in-person university bootcamp in Montreal, Canada, that teaches you this critical skill of how to think like a computer. Full disclosure, I'm going to be honest with you here. I want to turn you into a believer that there's a better way to become a developer. By the way, Wakata, which means I understood in Japanese, was first launched in the summer of 2018, and I keep improving it and releasing new tools within the platform to help its users become even more masterful developers. It's completely free. You don't even need to sign up to use it. By the end of this workshop, it's my goal to make you see that my unique method of teaching you about coding, which is housed inside the Wakata platform, is the solution to the horrible problem that has infected our industry and is doing a massive disservice to everyone who aspires to be a programmer someday. But the typical way of learning to be a developer is broken, that it fails everyone with a genuine desire to become a proficient coder. So let's explore a bit more as to what I mean by the current become a developer system being completely broken. It seems a little bit arrogant of me to say that after all, but it's the truth. You have all these brick and mortar universities and colleges out there, and all these in-depth courses and boot camps and other resources online. And even though all these people are putting huge amount of effort into educating their students, everyone is doing it wrong. And it's an open secret in the teaching community that the long-standing teaching methods are broken. And we're not training effective software developers. Teachers know that the system is broken, but they don't know what to do about it. In fact, there's a researcher who put it quite succinctly when he said, at the moment, the way in which programming is taught and learned is fundamentally broken. And this is something that I've noticed in my classroom, as we'll see in a bit, when I was using traditional teaching methods. In fact, a basic programming task was given to 216 students after the first year in computer science. The average score was 21%. That is not okay. And this is why I created Wakata. This abysmal average score points to the fact that something very big is missing in the curriculum of computer science programs. Not just computer science, this is in all different kinds of educational institutions and educational methods for programming. It's common knowledge that the so-called fundamentals are the most important part of being a software developer, but no one is teaching the actual fundamentals to students. There's an absolutely critical body of knowledge that is entirely ignored by virtually everyone who professes to be able to teach people to code. This is a serious, tragic problem. This body of knowledge, whose importance nobody seems to clue into, is how a computer's brain operates and what we need to do to communicate effectively with it. What do I mean by this? Allow me to explain. We write code to communicate with computers. There are two types of things we can do when we communicate. Number one, we can tell a computer to do an action, such as display an image or play a sound or communicate with another computer. But there's another aspect of communicating with a computer that is so much more important and so poorly understood. That's the aspect of coding that involves giving the computer information that will alter its memory. So, doing an action are things that we perceive as users, such as displaying an image or playing a sound. There are many different kinds of actions that we can give to computers. Modifying a computer's memory, however, does not actually change what the user perceives. It changes the computer's behavior. It changes what will be displayed, what songs will be played, etc. So when you're a developer, every line of code you write, you should be asking yourself, how does this modify the computer's memory? Because that's the only way you're going to truly understand what's happening inside the computer's brain, and be able to write reliable and effective code. But this question doesn't even enter most people's minds. Sure, they might end up learning it implicitly after years of practice, but there will still be some erroneous assumptions. You'll get an approximate understanding of how a computer's memory is modified, but there will be gaps. So the way you'll handle coding is by engaging in a lot of trial and error, which is obviously tedious and frustrating and won't get you good results. You're going to miss many opportunities to write beautiful code because you're just hacking your way through it. And if you manage to land a job as a developer, you might regularly miss deadlines, get poor reviews, or even get fired because your boss will realize that deep down you just don't get it. When I was teaching at Concordia boot camps, which feels like another lifetime ago now, I had many students that after 2 months of intensive study still did not understand these basic principles of how a computer's brain functions. And to be completely honest with you, it was shocking to me. As a teacher, I was doing it like everyone else was, and my students were not understanding some very fundamental things at the end of their course of study. I was very concerned about their future. I would get the class to participate via questions. There was this one time that when I put a relatively easy question on the board and asked them to answer them. Half the class got it wrong, when I thought for sure they would get it right. That's when I realized, oh, there's a big problem here. Everyone in the class should know this, but they don't. So, I created a tool called CompuThink that allows you to visually see how code modifies a computer's memory, step by step. By showing you this visually with true immediacy, you quickly begin to grasp how the code you're writing alters the brain of a computer, which allows you to stop playing internal guessing games when you're writing or debugging code. This has an incredible positive effect on your ability to reliably get a computer to do what you want it to do, which is the whole point of being a programmer. Rather than leaning on your intuition, which operates according to erroneous assumptions that the human mind and the brain of a computer work the same way when you're coding, you'll actually be able to switch over to an alternate way of thinking, which is defined by thinking exactly the way that a computer does. It puts you in a position to become one of the best developers out there, in a sea of so-called developers who actually have no idea what they're doing. When I shared CompuThink with my students, they finally got it. It was amazing. The kinds of questions I was being asked before and after my students used CompuThink were like night and day. I started to have faith in their futures again, and I knew I was onto something big. Today, after my students have used CompuThink and the other tools inside Wakata to hone their coding skills and land fantastic development jobs on the very first interview, I know that this new way of learning to code has played a huge role in fixing that glaring problem that exists within our industry. Most devs don't understand how to think like a computer, and that we all need to train our brains to think this way if we want to position ourselves for the best possible degree of success in the software development world. I'm excited to share CompuThink with you today as a powerful introduction to the Wakata platform, so that you can start to empower yourself with a skill set that is so painfully absent from the other learn to code opportunities that exist today. Recently, researchers have gone out in the field and started to catalog the misconceptions that students have. In a paper published in 2018, researchers identified 40 common misconceptions. No one is addressing these problems, and the status quo is terrifying. Students are failing to solve easy problems because of a lack of understanding. Students deserve better. Let me demonstrate with one simple example. Before I jump into this misconception, which is one of the most common misconceptions that beginners have about programming, let's go over a short introduction of how computer memory works. Right here, this is the Wakata platform. And the middle section, you have the computer memory. On the left-hand side, we have the code that will modify the memory. Let's see how the code modifies the computer's memory. I will now demonstrate. When we add a variable, what we're actually doing is adding a row in a table where all the variables are stored. And there you have it. In the center part right here, we have a table with two columns. First column has the variable names, and the second column has the variable values. So we say that x has the value 5 and y has the value 7. Any questions here? So variables are stored in variables are stored in two-column table for all programming languages. Every single one, even the really, really, really strange ones. And there are thousands of programming languages. So here we see a computer program with console log. What console log does is it takes a value and displays it to the user. In this case, in the simulation, the output of the console log, the results of the console log will be right here on the bottom right. So let's go ahead and see what the result will be. Can anyone guess what will be console logged? If you can, put it in the chat. Nathan says 7. Okay, let's see if Nathan is right. And Nathan was right. 7 gets, we say outputted to the console. So we say the output of this program is 7. And the way the computer does this is it looks up y in the table. So a computer never refers back to previous code. It only looks at the table. The table is its memory, and every line is interpreted in the context of its computer memory. So here is an example that actually beginners find very confusing. We were building up to this example. So my question to you is, what is the output of this program? In other words, what is y going to be in the table by the time the computer reads line number 4? So Mia Urbis says 5. Do we have any other answers? Heather Ward also says 5. Heather Ward writes, because it's a primitive and not a reference, I think. Good point, Heather. That's actually another very common misconception. But it's not exactly true. But it's somewhat true. Any other guesses? Is there a consensus? Keep note that we wrote y equals 5, y equals x right here. And then we wrote x equals 3. All right then. Let's see if Jotham Johnson writes 5 also. So there's a consensus here. Let's go ahead and actually see what's going on. Right. So we see here that we updated the value of x to 3, but that did not modify the value of y. Therefore, at the end, the answer is 5, as chat correctly guessed. Congratulations, chat. Last time I ran this event, half the audience got it wrong. So, before we jump into the next misconception, let's do a little bit of review. Here we have a program with 2 variable declarations. Each one assigns a variable to an object. So let's see how this computer program is actually modifying the computer's memory. We know we are going to create 2 variables, but what will these variables contain will be shown right now. Let me demonstrate. And there you have it. So we have 2 variables, Bob and Sue. Bob contains a reference to an object, and Sue contains a reference to another object. Any questions about this particular piece of code? All right then. Let's move on to the next example. The way that once you have an object, the way you can get the information out of the object is by using a dot expression. So in this example, we have a variable Bob that refers to an object with the property name, and then we can get that property name, the information stored in that property name. Oh, Mia Urbis has guessed that the output of this program is Robert. Mia is pretty quick. I agree. She was like, I know the answer. So let's see if Mia is correct. Oh. I just realized. Sorry about that, Heather. I just realized that I was blocking the console. So here we see that Robert gets outputted to the console, as Mia Urbis had correctly guessed. So here is this particular exercise, when provided to students, many students get it wrong. So let's see if you can correctly get it. Would the members of the audience please like to guess what the output of this program will be? Will it be Robert? Will it be Bobby? Will it be something else, like Sue? Please let me know in the chat. We have Heather who says Bobby, question mark. I'm going to guess the question mark means that there's a certain level of uncertainty in your answer. Jotham also says Bobby. So we have two Bobbies. Anyone else? We have Mia who says Robert. So I love this because we have a difference of opinion. And differences of opinion mean learning opportunities. Does anyone else want to join Mia's team? Or Heather and Jotham's team? No takers? All right. So, who's going to win? Is it Heather and Jotham or is it Mia? Let's check it out. And the answer is Bobby. But good guess, Mia. So Mia wrote, I think let Sue equals Bob creates another instance of an object. Very good observation, Mia. Unfortunately, it's not correct. So no new instance of an object is created. The only way you can create an object, as far as a beginner is concerned, is by using this little notation. So this notation right here is the only simple way to create an object. There are some more advanced ways that you will learn, maybe potentially when you become a more advanced developer. But 99% of the time, the only way to create an object is with the syntax right here. Niraj writes, Bobby, because I think Sue is a reference type. So Sue will contain a reference to an object. Bob and Sue both create references, both contain references, and they contain references to the same object. So something in that vein, yes, Niraj. Heather writes, I think that let Sue just creates another name and still points to Bob. It's a very good point, Heather. So Sue creates a name. Let Sue creates a name. The name is Sue. Let Bob creates a name. The name is Bob. So we call these variables, and a variable has a name, indicated by the first column of the table. Jotham writes, it changes the referent of the object, I believe. Or it changes the content of the variable to the object. So Sue, actually no, we did not change the reference. So it does not actually change the reference, Jotham. The references have not changed. The only thing that changes is the property. So property name, the value of the property is Bobby now. One key insight here, and something that many beginners struggle with, is that objects don't have names. In fact, functions don't have names. The only things that have names in JavaScript are variables and properties. So in this example, we have two variables, Bob and Sue, and we have one object with one property name. Nothing else in JavaScript has a name. I cannot stress this enough because it is very, very big misconceptions that objects have names and functions have names. It is not true. So, for the remainder of this workshop, I'm going to invite you to try the COMPUTHINK tool and to ask me questions in the chat, which I will answer. So before I give you the link, I will paste it in the chat in a bit. If ever you are stuck anywhere, there is a share a link button right here. If you click on this link, you can take what is written and paste it into the chat, and then I'll be able to see what you see and I can help you. Before that, I'd like to answer a question. Heather Ward writes, don't some functions have names? The answer is no. Functions don't have names, variables have names. So when you write, let me write what Heather wrote. I'll do it in the console. Heather wrote function some func. She claims that I'm creating a function with a name. This is absolutely incorrect. You're creating a variable called somefunc. So it's not the function that has a name, it's a variable that has a name. And that variable will contain a reference to the function. So thank you for pointing that out, Heather. So Mia writes, var somefunc equals function. And yes, that's exactly the same thing. So you're creating a variable that contains a reference to a function. There are two ways of writing the same thing. There are some very subtle differences between those two notations, but they're so subtle that 99.9999% of the time, it's exactly the same thing. So getting back to CompuThink. If ever you're stuck, you can open the navigation bar by clicking on the top right, and then you can click share link to get a link that you can post in the chat, and I'll be able to help you. So for the remainder of this workshop, you will be going over the CompuThink tool at your leisure, and I'll be here to answer any questions you have. Our workshop ends at 2:30. Also, feel free to ask any kinds of questions in the chat. I'm here to teach and entertain you. So anything you have, let me know, and I'll be happy to help. Just post. Right here. In the first tutorial, the instructions on the bottom right. So if you have a very small screen, you might not be able to see it, and you'll need to zoom out. So enjoy the rest of the workshop, and I look forward to receiving your questions. Heather writes, let me put my video back on. Heather writes, what is the difference between an anonymous function and a named function? Good question, Heather. So all functions are anonymous functions. I know, it's a shocker. The way that we use the word anonymous function, so in common literature, the way that we say we use anonymous function is when we pass a function like so. So we don't store a reference to that function in a variable immediately. That's what we call by an anonymous function. But as far as I'm concerned, all functions are anonymous. Heather writes, sorry, this is so confusing to me. I've been taught so many conflicting things. Yes, this is a problem. There's a lot of junk out there, Heather. It's unfortunate. This is why I built my tool. So all functions are anonymous. Variables have names. Functions don't have names. However, you can have references inside variables. And when people say the word anonymous function, they usually refer to the fact that you can pass a function to another function without first storing a reference to that function in a variable. So for example, people will say, oh, this code is regular code, and here's the anonymous function. So that's how people use the word anonymous function. I personally find the term anonymous function to be confusing. Since all functions are anonymous, functions don't have names. Niraj asks, is this only specific to JavaScript or is it language agnostic? The answer is, this is in all programming languages. The only exception would be C and C++. C and C++ do things slightly differently. Overall, it's the same idea, but there are some minor differences. However, Java, Ruby, Python, all the big programming languages, without exception, all use the exact same system. Which is why if you learn one programming language, it's very easy to learn another programming language. So what you've learned right here applies to every programming language you will ever use. Keep the questions coming. I'm here to help and answer them. Nathan writes, do you have any more upcoming courses? Good question, Nathan. I have a live stream right here. So every Monday, Wednesday, and Sunday I stream. And during my stream I build something, so it's a little more of an advanced topic. You can also add me on Instagram to find out what kind of events I organize. Let me get you a link to my Instagram account. The live stream is on this. This is the same link for this live stream. So you can use the link I sent you on Eventbrite to join my live stream. And you can subscribe to my channel to find out if I'm organizing any new workshops. I will post it in YouTube, as well as Instagram. Instagram is probably a better venue. Also on my Instagram, there are videos of the tools I'm creating to help my students. CompuThink is one of them, and I have other tools also. Basement Ghost asks, what is your favorite programming language? So that's a really difficult question to answer because different languages are used for different purposes. However, if you're talking about which language, aesthetically speaking, is my favorite, meaning that inconsequential of the way it is used, inconsequential of what it can do, just what is the language which has the nicest structures, in my opinion, for myself, is a language called OCaml. That is very obscure and that no one uses. Well, very few people use. There are a few companies that use it. For example, there's a company in New York that uses it called Jane Street Capital. Unfortunately, it is a challenge to debug, so I don't use it very often. These days, at least. I used to use it quite often before. Number 2 in my list would probably be Scala. So Scala is another programming language. So what I like about Scala is that it's easier to debug. However, linguistically speaking, I prefer OCaml. As far as debugging is concerned, I prefer Scala. And number 3 would be JavaScript. So JavaScript is quite nice, especially the newer versions of JavaScript. And JavaScript, from a application perspective, lets you do basically anything you want. So you can do front end, you can do back end, you can even do data processing. You can do a little bit of machine learning too if you're interested. So those are my top 3. OCaml number 1, very obscure. Scala number 2, a little less obscure, but still quite obscure. And JavaScript number 3, which is very mainstream. That's the end of today's stream. Thank you for joining me. I hope I was able to clear up some misconceptions that you may have had, and more importantly, helped you realize how important the fundamentals are, and encourage you to work on those fundamentals so that you can learn more effectively and become more effective software developers. If you have any questions, my email is in the chat right now. You can also add me on Instagram and direct message me on Instagram, or you can use the chat feature in the nav bar right here, where you can reach out to me, and in this chat window I usually answer in 1 day or 2. Thank you for participating, and have yourself a nice day.